So in this video, we can drop water into a sink and we can see the wave traveling out. We can also change this so that we can see it from a side view. And we notice that the wave is traveling to the right, but the disturbance is from the drip going up and down. And we can adjust the frequency. So I'm going to increase the frequency. And I can see how that changes the wave. It still travels to the right, but the crests are now closer together. And so that means that if I were to measure, let me pause this, if I were to measure the wavelength, which is the distance between crests, in this particular case, it would be different than if I were to measure the wavelength if the frequency was increased. So if I increase the frequency and then I want to measure the wavelength, let me go to another crest, I notice that the wavelength here is less. So as the frequency increases, the wavelength decreases. The other thing to keep in mind is that the wave has a particular speed as it's traveling forward, and I could measure the speed by just sort of measuring how long it takes the wave to go from one location to another. If I change the frequency, the wave would still actually have the same speed. And the other thing to keep in mind is if you were to put something like a leaf or something on this water, the leaf would bounce up and down because it would be sitting on the water, but it wouldn't actually travel forward. So a wave is a traveling disturbance, the disturbance in this case being up and down, and the wave is actually traveling forward. But something on the water would not physically move with the wave, it would only move up and down.